are starting our unit on circles. Circles is kind of a big unit. Circles have a ton of properties, okay? They also have their own unique terms for different parts of circles and different lines that go through them and touch them and all that stuff. So basically, a circle is the set of all the points in a plane that are equidistant from a point called the center. What does equidistant mean? The same distance, the same length, okay? So a circle is all the points that are equidistant from a center point. We know it by its basic shape. It is round. It goes around. A chord is a segment that has endpoints on a circle. So for this example, this one up here, I have it labeled C on the figure. It is a chord because its two endpoints touch the edge of the circle. A diameter is also a chord. Okay? So a diameter is special because it's a chord that goes through the center. So a diameter is any chord, so it touches endpoints on the edge of the circle, but it goes through the center. Okay, that's what a diameter is. A secant intersects the chord in 2 points. So it basically is a line that shoots through a circle, like on this one down here. So if it goes all the way through and touches the circle in 2 points, it's called a secant line. If it only touches the circle in 1 point, it's called a tangent. So if I touch it once, it's called tangent, just on the edge. If I could touch it in 2 points and go through the middle of it somewhere, not exactly the middle, but go through the circle, it's called a secant. Okay? So any questions on any of those terms? Chords? I didn't even talk about radius, did I? No, I didn't mention what a radius is. What is a radius? Half of a diameter is from the center to the edge. Okay, so a radius is a half of a diameter. Sorry, I don't understand why I don't have that definition there. But there you go. Open your book to page 651. And let's look at example 1, pretty please. It says, tell whether the line, middle of the page, tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. So, problem A is talking about segment AC. So, y'all are looking with me on page 651 at example 1. What would you call AC? A radius. Very good. Because it's half a diameter. It goes from the center to the edge. All right. What about part B says segment AB? What is AB? It's the diameter of that circle. Very good. Part C is asking about the ray DE. What do you think DE is? It's a tangent, right? It's touching that circle. If you look at the graph, DE touches it one time, just on the edge, so it's a tangent. I can't spell tangent. And then D part, it's line AE. What is AE doing with that circle? It goes all the way through it and touches at points A and point G, so it is a secant. Does that make sense? Right. See what example 2 looks like. Okay, flip over the page while you're there at for example 2 on page 652. Those are some circles, A, B, C, and D, graphed on a coordinate plane. Does everybody see those? Y'all see those on page 652? So if you're on page 652, turn the page. You should see 4 circles on example 2, graphed on a coordinate plane, right? All right, so if they want you to find the radius of circle A, could you do it? No, okay, something I need to tell you. Circles are named by their center point. So circle A is the one that has point A for the center. So it's the blue circle. So how would you find the radius, for example? You can count from the center to the edge. So how many units is from the center of, or where point A is to the edge of that blue circle? 3. So if the radius is 3 units, what's the diameter? 6 units. And again, if it's on a grid, you can count the radius. Does that make sense? All right. What do you think is the radius then for circle B? 2 units, so the diameter is 4. Okay, what about circle C? What's the radius? 3. It's the same size as circle A, isn't it? And D is the same size as circle B. Y'all see that? Okay. All right, so there's that. Let's also talk about like the pictures on that same page down there. Coplanar circles. Circles can intersect. They can either overlap or they can touch and be tangent. Okay, so do you see the first pairs of circles are overlapping circles? Y'all see that? The middle one are tangent circles. They only touch on the edge. Concentric means they have the same center and their edges never touch. So they can be different sizes but have the same center. So there's some just different ways circles can intersect in the same plane. All right, here's a theorem. And so you need to write this on your handout. I don't think I drew the picture for this theorem, did I? So you need to draw the picture for this theorem too and fill in the blanks. Theorem 10.1 says, in a plane, the line is tangent to a circle if and only if the line is perpendicular to a radius of a circle at its endpoint on the circle. So it's kind of wordy. So what are the blanks we're filling in? All right, I have them highlighted. Okay, so the first word you're filling in is perpendicular. Tangent. I lied. If and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So please draw that picture. A line is tangent to the circle if it's perpendicular to a radius. Perpendicular means it intersects to form a what? A right angle. So what does that if and only if mean? We've talked about that phrase before in geometry. That means the way it's written is true and the converse is true, right? If and only if means it's true both ways. So if we have a tangent line to a circle, it's perpendicular to the radius. And if we have a radius of a circle perpendicular, then the line is a tangent. Okay? So there's that one, and there's a little space below where you can draw the picture. And I think next we're going to work a problem. So I'm going to scroll just a little bit so y'all can go ahead and draw the next picture. Because we're actually going to work a problem. So do this one on your notebook paper. There's not room on your handout, unfortunately. Now what we call the symbol for a circle is a circle with a dot in the middle. And then there's a letter beside it. The letter is the name of the circle, and it's also the name of the center point of the circle. So we name circles by the center point. All right, can I scroll some more now? So we got to verify that a line is tangent to a circle. So they tell me that segment PT is a radius of circle P. Okay, so P is the center. Is segment ST tangent to circle P? You can't just look at it and say, well, it only looks like it's touching it at point T, so it looks like it's a tangent. You can't say that. You have to verify it is, using that theorem we just said. Okay? So the theorem we just saw said, if something is a tangent, then it's perpendicular to a radius and vice versa, right? So I have to prove that this is a right angle. How do you think I can prove that that is a right angle? How can I prove that that is a right angle? Because I'm proving that this line right here is perpendicular to this radius. Okay? That's what has to happen. You have to show that that is perpendicular to it. So I have to prove that that makes a 90-degree angle. And if that makes a 90-degree angle, then yes, it's a tangent. So how can I do that? What shape is this? Triangle. So if it's perpendicular, then it would make a what kind of right? What kind? I just said it. What it was? It would make a right triangle, right? And do I know all three sides of that triangle? Yes. And if it's a right triangle, then what? Then what? Then Pythagorean theorem is true, right? If this is a right triangle, then the sum of the squares of the lengths of the legs of the right triangle is equal to the square of the hypotenuse, otherwise known as a squared plus b squared will equal c squared, right? The sum of the squares of the legs of the right triangle equal to the square of the hypotenuse. Yes, otherwise a squared plus b squared equals c squared. So which one would be the hypotenuse? 37. So if 37 squared, if that equals 35 squared plus 12 squared, then that's a right triangle, which means that's a right angle, which means those lines are perpendicular. Therefore, it's a tangent. Okay? So that's how you verify it. So hopefully somebody has their calculator and can participate with me. What is 37 squared? Yep, 1369 equals what's 35 squared? Thank you. 12 squared. If I add 144 plus 1225, do I get 1369? So is it a tangent? Yes, because it's perpendicular, because the Pythagorean theorem was true, making it a right triangle, meaning we have a right angle right there where we need to at point T. So that's how you verify something is tangent. You use the Pythagorean theorem. Okay? And I'm smiling because this next problem is awful fun. Can I scroll? We good? Can I scroll? Go ahead and draw that picture, please. The algebra teacher in me is dancing. Because when algebra and geometry collide, it's beautiful. We're going to have to do a little bit more fancy algebra this time. Now this one's worded a little bit different. We're going to be finding out something different. Okay, it tells me that in this diagram, B is a point of tangency. What do you think that means for it to be a point of tangency? Sounds fancy, doesn't it? B is a point of tangency. All right, it's the point on the edge of the circle where the line is tangent to it, right? It's where the tangent line touches the circle. That's what a point of tangency is, where your tangent line touches the circle. It's on the circle and it's on the tangent line. It's where they intersect. Okay? So B is my point of tangency. That means that AC is tangent to circle C, or AB, I'm sorry, is tangent to circle C at point B. Okay? So that tells me this is a 90-degree angle because these two have to be perpendicular to each other. Right? They told me it was tangent. That's how I know it's perpendicular. Does that make sense? If they tell you it's tangent, you know it's a right angle there. Find the radius of circle C. Those are what those R's mean. Right? Now this is not an easy problem. So, what shape is ABC? What kind of triangle? It's a right triangle because they told me this is a tangent line because they said this is a point of tangency. Right? So they tell me AB is tangent to circle C. So I know this is a right angle right here, making that a right triangle. Right? So if I have a right triangle, then I have the Pythagorean theorem, correct? So that means the hypotenuse square will equal the squares of the lengths of the side. Okay? So what is the hypotenuse of this triangle? Across from the right angle, so it's the side AC, right? What's that measure? 50 plus R feet. I don't know R, right? And it ain't just 50, it's 50 plus the radius. All right, I'm going to change that around to say R plus 50. So R plus 50 squared. So I'm doing it backwards. C squared equals A squared plus B squared. Is that okay with y'all? Equals, what are my legs? 80 squared and R squared. Now, y'all, let's go back to algebra. Let's go back to Algebra 1 specifically, which was just last year. Right? For some of you, it was last semester. What does it mean to square something? Multiply it by itself. Okay? So this R plus 50 squared means R plus 50 times R plus 50. Do y'all see that? I'm going to write it on my screen for my YouTubers. All my followers in the house. So R plus 50 squared means R plus 50 times R plus 50. Now back in the Algebra 1 days, we called this FOIL method. Y'all remember that? A binomial times a binomial. Guess what? Here it is coming to kick you in the butt in geometry again. Okay? And guess what? In Algebra 2, it's going to come back and lopside you upside the head. It's forgetting your butt. It's going straight for the head. Okay? This is something we got to still know. So, remember first, outer, inner, last. Or you can think of it, multiply R times both terms and multiply 50 times both terms. So R times R is R squared. R times 50 is 50R. And then you do 50 times both terms. 50 times R is 50R. And 50 times 50 is what, people? 2,500. And aren't these like terms? Yeah, the R's in the middle are like terms. So R squared plus 100R plus 2,500 equals, now I'm going to come over here and work on my other side. What's 80 squared? 6,400. And I don't know what R is, so I'm going to call it R squared. Beautiful equation. So if you have a binomial, which R plus something or whatever squared, you multiply it times itself, which was good old-fashioned FOIL method. Okay? All right. Now, if I want to get my R squares together and I subtract them on both sides, what happens? They cancel out, don't they? Right? So you're going to cancel out your R squares on both sides. If you don't believe me, you can subtract them on both sides and they both make 0. Okay? So I'm left with the equation 100R plus 2,500 equals. Then you just solve that for R. How are we going to solve that for R? Subtract 2,500 So 100R equals, what's 6,400 minus 2,400? 3,900. And then how do I solve for R? Divide by 100, which means I can cancel out these zeros, right? So R equals what? 39 what? They give units, you gotta give units. So the radius of this circle is 39 feet. And you can check it. 50 plus 39 will be 89. So 39 squared plus 80 squared should be 89 squared. Okay, that should equal. That's kind of like a fun doozy problem, right? Just remember, if you have R plus a number squared, you got to do that times each other and FOIL it. Okay? And then luckily the R squared should cancel out. You will see these again shortly. All right, let's do another one on our notebook paper, please. First of all, here's a theorem. This is the one on the bottom of your page. The first page of your packet. You might want to draw the picture. This one is usually a little bit easier to work with. Tangents, segments. That means two lines that are tangent from the same common external point are congruent. So if I have two tangent lines that go to the same point outside the circle, that's what external means. External means outside the circle. Then they are congruent to each other. Those two segment lengths are congruent. So if I have two tangent lines and they're going to the same point outside the circle, they are congruent to each other. So the two fill in the blanks are common and congruent. And then there's that lovely picture. So back to our notebook paper, we're going to work a problem dealing with this, and it's really simple. I'll do it like this for a second so y'all can see both pictures, hopefully. You don't have to write this. But they tell you that segment RS is tangent to circle C and segment RT is tangent to circle C because they both connect to R and they're both tangent. They tell you that. Find the value of X. Well, besides knowing that both lines are tangent, what else do I know about those two segments? They're congruent because they both go out there to point R, don't they? Right? So I know that SR is going to be congruent to TR. Therefore, how do I find X? Right, I can set both sides equal to each other. And then I can solve it for X. So how do I do that? Subtract 4 on both sides. So 3x equals 24. And then what? Divide by 3. And then equals 8. Did they tell me any units on this one? Did they tell me units? Feet, centimeters, anything like that? No. So we can just leave it x equals 8. And you can check it. 3 times 8 is 24. 24 plus 4 equal to 28. Okay. Well, what I want y'all to do right now is I want you to try one of these hard ones on your own. Try this one on your own. And it's just like that difficult one we did a while ago. If you need a calculator, you are welcome to one. feel free to check it with somebody if you think you get an answer. I'll tell you, go ahead and tell you. I will go ahead and tell you that it's a whole number, not a decimal or a fraction. All right, y'all help me out. It says ST is tangent to circle Q. Find the value of R, which is the radius. Okay? So if ST is tangent to it, what does that mean? It's also what? Perpendicular to a radius, right? And if it's perpendicular to a radius, it makes what figure? What kind of triangle? A right triangle. And if it's a right triangle, then what? The Pythagorean theorem holds true, right? So, what's the hypotenuse? Well, I'm going to do it R plus 18, just because I like my variables to come first. So, if I square the hypotenuse, which is R plus 18, that should equal the two legs squared. So, what are my two legs? R and 24. And it doesn't matter the order you put those in. How do I square R plus 18? Multiply it times itself. So FOIL method. Okay? So y'all help me out. R times R is what? What's R times 18? And you got that again. 18 times R is, and what is 18 times 18? 324 equals R squared, can't do anything with that, plus what's 24 squared? 576. Did everybody get that at some point? And then those are like terms, so we can go ahead and simplify that. 18 and 18 makes 36R. What do we do with our R squares? Cancel them out, because if I subtract them on both sides, they go away. So now I've just got the equation 36R plus 324 equals 576. So 36R equals what number? Evenly. 30 sides by 36. You got that? Oh, y'all are geniuses. Very good. So, y'all, this is kind of like, we haven't done algebra this involved in a very long time, have we? Okay, so that was a good little refresher. All right, so that is the end of section 10.1. So, flip over your handout to section 10.2. We're going to learn some new terms. So feel free to go ahead and fill in the blanks. I think I have underlined all the correct parts of the blanks. And also, please draw the picture so that you know what a major arc and a minor arc looks like. So section 10.2 in this circle unit will be dealing with finding arc measures. Okay? So before we can understand what an arc is, we first need to talk about a central angle. A central angle is an angle inside a circle where the vertex is the center of the circle. So for this picture down here, this right here is the central angle. Okay? So these two radii, AC and CB, have a vertex at point C. That is the central angle. It has to be at the center point. It can't just be at any point in the circle. It has to be made with the center of the circle. Okay? The minor arc is the area of the circle that is in between the central angle. Okay, so the 2 points that make the vertices or the edges of the central angle, that part on the outside of the circle is the minor arc. Okay, it's less than 180 degrees. So if it makes a diameter, then it's not a minor arc. Okay, minor means small, major means big. Okay, so the major arc is the parts of the circle that are not in the minor arc. So everything around from A to B going the long way is the major arc. So if it's less than a semicircle, it's a minor arc. If it's greater than a semicircle, it's a major arc. Okay? And the semicircle is an arc where the endpoints are the endpoints of a diameter. And you need to note that that's 180 degrees. What is the angle measure for an entire circle? 360 degrees. So if you go 180 degrees around, it's a semicircle. Okay, so minor arcs are less than 180. Major arcs are greater than 180. If it equals 180, it's a semicircle. Okay, here's how we name arcs. And you might have room to put that somewhere on that page. Over to the side if you drew the picture. If you're naming a minor arc, you're going to use 2 points. If you're naming a major arc, you're going to use 3 points. The 2 endpoints and a point between. So minor arcs have 2 endpoints for the name. If you're doing a major arc, that's how you know by the name if it's a major arc, is if you see 3 letters, the 2 outside points of the edges of the arc and 1 in between. So for like this first example up here, if you had like a point D hanging out there somewhere in between it. Okay, but the 2 on the end are the endpoints. So minor arcs need 2 points, major arcs need 3, and you put this little like arc symbol above it, a curved line, kind of like an upside down parentheses. All right, that's how you name an arc. Now let's talk about measures. So this is a fill in the blank on your paper. Pretty sure it is. All right, the measure of a minor arc equals the measure of its central angle. The measure of a minor arc equals the measure of its central angle. So if it's a minor arc, you're going to fill in the blank there, the measure of its central angle. And for a major arc, you're going to do 360 minus the minor arc. 360 degrees minus the minor arc equals the measure of a major arc, which should be greater than 180 degrees. So minor arcs have to be less than 180. Major arcs will be greater than 180. This will make more sense when we work some problems. Which is coming right now. Draw this picture on your notebook paper. That's terrible handwriting in there. That's supposed to be 50 degrees. So we want to find the measure of minor arc AB, which is the little one that's less than 180 degrees. on the edge of the circle. And the measure of the major arc from the edge of the circle, ADB, which is the big area. The minor is the little, major is the big. All right? Now, what did we just say was the measure of a minor arc? The same as the measure of the central angle. Do we know the measure of the central angle? What is it? 50 degrees. So this arc, this minor arc, will also be 50 degrees. And we put degrees on them just like we do central angles. Okay? So arc measures have degree symbols as well. So the second part wants the measure of the major arc, ADB. And I know it's talking about a major because there's 3 points. So it goes from A around through D and back to B. Okay? So how do we get the measure of a major arc? Right, we say 360 minus the minor arc. So what's 360 degrees minus 50 degrees? How much? 310 degrees. And that number needs to be a number between 180 and 360. Okay? So any questions on how I got those two? It's pretty simple. Okay, look at this one. They have 3 arc measures they want us to find. And they give me 1 central angle. So y'all don't have to draw the picture if you don't want to. You can just help me fill it in. I think you can tell by looking at my screen. Also, it's on page 569 if you want to just refer to it in your book so you have one handy. They tell me this central angle right here is 110 degrees, correct? Correct? If I wanted to, could I find this central angle? How would I do that? Yeah, this makes a linear pair, doesn't it? Right? They're supplementary. So I could do that if I needed to. I don't think you're going to need to, but you might. So, first they want me to find the measure of arc RS. Is it a major or a minor? Minor. So R to S is here to here. And what's that going to be? It's going to be the same as the central angle, so 110 degrees. Does that make sense with everybody? Does everybody understand why that's 110 degrees? Okay. Then they want us to find the measure of RTS. So that means you got to go the order it says. R to T to S. Is that a major or a minor? Major. And so if this minor one was 110 degrees, how are we going to find the measure of RTS? 360 minus 110. What is 360 minus 110? 250 degrees. Does everybody understand that one? Yes or no? You got it? All right. So the last one they want me to find, you got to go in the order of how it goes through the points. RST. Goes from R to S and stops at T. Well, what is that? It's halfway around the circle. So that's called a semicircle. And every semicircle's measure is what? 180 degrees. So any questions on that? Y'all understand doing the points in order? Okay. Very good. Let's do this example, then we'll skip the next one because I think it's pretty much the same thing. We want to find all those arc measures. You can't read that. This one's 29, this is 79 degrees, 61 degrees, 83 degrees, and 108 degrees. What do you think their total is? 360. So if they didn't give you one, could you find it? Yeah. All right, first they want us to find the measure of AC. So is that the major arc AC or the minor arc AC? So that means it's the short AC, right? So I'm going the quickest way from A to C. I am going through B, but I don't have to include that in the name because it's part of a minor arc, not a major one. Does that make sense? Okay? So that's how you know if you're doing the short distance or the long distance, if it's a major or minor. 2 letters mean minor. How are we going to find that measure? Right, because I'm going to add these two central angles, and whatever that angle measure is, that's my arc measure. Correct? So what is 108 plus 29? 137 degrees. Does that make sense? Okay, let me erase that. Then I want ACD. So I'm going all the way around to D, but I got to go through C from A. So ACD. Now I can do this 2 ways. I can add these 3 angles, or I can add these 2 and subtract from 360. Does that make sense? I think I just want to add. We already know this part, though. It's 137, right? So we can say 137 plus 83, 220 degrees. Does that make sense to everybody? All right, next I want the measure of ADC. So do I start at A and go this way, or do I start at A and go this way? Yeah, I got to go from A to D to C in that order. Yeah, this way. How can I do that? Yeah, I can add 79, 61, and 83. Or since I already know this is 137, I can say 360 minus that part. Right? Does that make sense? Because I know this part is 137, so I could say 360 minus that. Either way, what do you get? 223 degrees. Does that make sense? And then EBD. Oh, this is going to be really easy. What's the best way to do this one? 360 minus 61. And what does that get you? 299 degrees. Very good. So any questions on how we found those? All right. Then I have another example on here in my notes, but we're going to skip it because it's basically the same thing. Okay? It's the same thing. All right. I want us to do our last 2 fill in the blanks. 2 circles are congruent if they have the same radius. So circles and radius are the answer to the blanks on the next to the last theorem. 2 circles are congruent if they have the same radius. So if they have the same radius, they'll have the same diameter, right? Because you double the radius, get diameter. And then 2 arcs are congruent if they are the same measure and are on the same circle or a congruent circle. So 2 arcs are congruent if they have the same measure and are on the same circle or a congruent circle. So we will do some more with that probably tomorrow. And that is pretty much the gist of sections 10.1 and 10.2 on circles. So any questions before I wrap it up for the day? All right. Have a good day.